Okay, real fast. We're on 11.6, number 40. Okay, Miss Smith said let's divide by 25 first. When we've got E, is natural log or log a little bit more convenient? Natural log, why is that? Ooh. I'm left with X, ln of E. Ln of E is how much? 1. Boom. What do I have to do on that right side? ln of 40. Yeah, don't forget, if we natural log the left side, we got a natural log the right side. Am I okay with that final answer? Ln of 40. Yeah. I really am. You can go get a decimal version. What is the natural log of 40? 3.69. Thanks, Nat.
What is a natural log? What does that even mean?
Well, it is used to help solve functions. These are called exponential functions when the variable is in the exponent. Okay. So it's just, right, we're not used to, oh, I thought you had something in your hands. Solving like our multi-step equation skills are when that variable is not in the exponent.
So why can't you just do square root of?
The xth root, you mean?
Yeah.
Yeah.
It's the xth root.
I'll do the first part again.
Let's flip it, to this guy. You guys, could I use natural log?
I just looked at what the problem is and it looks different.
Can I use natural log or log on this one?
Either.
I could use either. Is one better than another in this case?
No, because there's no E.
Right. They're going to be, I think, in my opinion, the same amount of work. So which one do you want to use? I agree. Like, you could use natural log every time. What are we going to say? Yeah, you're saying bring it on out. We got x natural log of 5 equals? Nice. Don't you be forgetting that final step. Bless you.
Can I make up a problem? So
Yeah. Look at that. And I love that response so much. Natalie just said, why can't you do the... And then other people said, you can. Nat, you're exactly right. We can. So you guys, if 5 was our base, we go around that equal sign. How would you write that, Nat?
5
Log
5.
base 5.
7 with 6 equals A.
Exactly. Can we go type that in our calculator? Is one way better than another? I wouldn't say so. Let's go see if we get the exact same equation answer.
ln mean natural log?
I know,
natural?
it's a little frustrating.
Is that what it means?
Logarithmic
It's like
naturalis.
Spanish.
Exactly.
You know how similar it is?
To what? Did you tell them what the E stands for?
Do we get the same answer no matter which way we go?
Savina Rio.
Okay.
You spell it wrong.
I didn't spell it that way.
What are we doing first on 70?
You did an element.
Yeah, we're team natural log now? I'm fine with that. What do we got to make sure we got? Parentheses. Now, Nat, you're saying your team log?
Yeah.
Okay, go for it. You guys have got X's on both sides. What do we have to do?
Subtract the x ln of 2.
Yeah, because you're saying I'm going to distribute and have an XL and a 2. He's like, I already did that. Get with the program.
That's something we said.
Okay, you guys, are you down with me subtracting my X to that side? Sure, she says. Can I factor out an X now from that side?
Yeah.
Leaving me with what on the right side?
3 ln of 5 minus ln of 2.
I thought you said you weren't talking anymore.
That's a lie, and you know it.
Yeah. It's specific people in this class.
Oh, okay.
I'm sorry, Evan.
Yeah, it got personal.
No, what do you know?
What'd you say, Beck?
It got personal.
It did. So I got negative 0.168.
Yes.
Yes, great.
Good job.
Okay, you guys, check this out. On this 11.7, here's the only thing I really need to show you. Jenny Euler, not to be confused with Euler for Euler's number, which is?
2.717.
Yes, 2.718. Euler's number is just that constant.
Constant represent.
What?
Where's the constant represent?
2.718.
Yeah, what does that represent?
Oh, the number, the constant that is used in exponentially increasing functions. Just like pi is a constant, 3.14, used in circles with circumferences and diameters. 2.718 is the constant used in exponential growth and decay. How did Euler come up with that? No idea. Okay, Jenny is depositing money in an account. It earns 6.3%. Compounded continuously, just to remind you guys, compounded continuously is our PERT. How long will it take for her to double the money? Is it just me or do we have a lot of unknowns here?
No.
We got to find T. We know we're looking for T. Do we know R?
Yes.
So we know we got E to the R is what?
0.6
Agreed. T, we don't know. What are we gonna put for?
1,000, 2,000.
Sure, but why'd you say she's investing 1,000? What if she's investing $4?
Pick any number and just double it.
Exactly. You guys, could we take $4 as my principal investment and say she's gonna make 8? Well, wait, let's make it easier. What would be the easiest?
1 and 2.
If I put 1 there and double it, it's a 2. I'm just gonna show you if we chose a 4 and an 8, what would be your first step there? Divide by 4, and what are we left with? What's 8 divided by 4? I'm left with a 2 equals 4 divided by 4? 1 e to the 0.063t. So is this at y? You can just jump to make my principal investment 1. It's going to double be 2 every time. So you could just save this little step if you wanted. Evan said 1,000 and doubled is 2,000. Agreed. Divide by that 1,000, you're going to be left with a 2 there. So you could just jump right here. Don't dump right there. Jump right there when you are looking to double something. Yeah, Ev. Yep. So T is always going to be in times in years. Guys, how are we going to what are we going to use to get that variable out of the exponent? Yeah. So what do we got on the left side?
0.063.
Nice.
ln of e.
0.063t. Anybody skipping this step of writing ln of e now? You're welcome to. The only reason it helps me is to remind myself that I got a natural log the other side too. You do not need to write that ln of e though. And aren't we dividing by that 0.063?
Yeah.
How many years for her to double that money? Doesn't even matter how much she's investing. 11 years?
Yep.
All right, 11 years. It's kind of a long time. But if you invest your $1 million, you're making $2 million in 11 years.
That's good.
If you want to take your $1, it's going to become $2 in 11 years.
That's bad.
Cool. Look at this last one, and then, yeah, let's just do this guy, and then we're done. We don't know who we're talking about, just a he, investing money so he will have enough to purchase a car that costs twice that amount when he graduates in 4 years. If he invests $4,000 in the car and it pays 9.5% compounded continuously, will you have enough money to buy the car? What are we going to do?
We do the a equals p 1 plus r over n to the n to p.
Oh, that was really good memory, but just compounding continuously is just still pert. Yeah, it was worth a shot.
That was good ambition.
Just do me a fave. Let's act like we're solving for t. Let's just act like we're solving for t and see if we're going to reach it in 4 years. So what do we want my A to be? If he's investing $4,000 and that car is going to cost double that. $8,000. You could skip this step though, right? We're investing $4,000. Could we just put a 2 and a 1 over here? Sure could, but I'm not going to. What's the rate? 0.095. I'm going to leave a T there and see if it's going to equal 4, more or less. If we set it up this way, yes, Evan?
We get 4 though. Like, what's the point of solving?
I know. I'm making it so that we had to practice ln one more time. I know. I'm making this harder. 2 equals e to the 0.095t. What do we got to do? Natural log both sides. Thanks for saying it that way. Let's go see. ln of 2. He not going to get it?
7.2.
Oh, gosh. Poor guy. 7 years. Nope. Not going to get that car. What would you have done? Because we really had all the information. What?
Plug in 4 for T.
Yeah, she's like, well, we could have just done 4,000 e to the, we're doing 0.095 times 4. Let's see how much money that's going to get him. Only $5,800. Is that getting him $8,000? And no, ma'am. That's what Mr. Acton would say. So here is the deal. If you flip the page. So now we're looking at this review. We've got the whole day. I want to go through and do a problem or two with you in each section. The review is a little lengthy. Do you have to do the whole thing? No. But I want you to feel comfy. We're going to have a formative of it on Thursday and then the quiz on Friday. Let's go take a peek-see at the review. Let's go with like 25 up here. Ready? All I want you to do is write that in exponential form. Boop. What's that going to be? To the equals. Boom. That's all I'm looking for up there. Okay, y'all? Oop. To your point, let's go try one right above it, bud. When I want to write this one in exponential form, you still, oh wait, why? These are all the same. Oh, sorry, buddy. Let's go do one of these. Let's go do, say, 27. What's my base here? 36, because it's the thing to the exponent. This is considered a base. So if I'm going to start at the base, go around the equal sign, hit 216, and then end at the last thing used.
What do you mean hit 216?
So meaning when I write this in logarithmic form, it's going to be a log. My base is 36. What's the next number I hit or came across? The 216 is going to go right there. Boom. Equals my exponent. So every time, Ev, you're going starting at the base, no matter which form it's in, going around the equal sign. So at this one, Ev, my base is 1/8. Go around the equal sign, land there. The base is whatever is to raised to a power. Okay? Okay, so Evan's going to practice all of those. Okay? Let's go do this. When I am expanding things, let's go do A, actually. If I want you to expand these, they've got one log used with division. How can I expand this into 2 logs if I've got division involved?
Log 17 to the 4 minus log of 5.
Yes, log of 17 to the 4th minus log of 5. Agreed. They want this to be as flat or as one level as possible. Hi, Mr. Richards. What can I do with that 4? Yeah, that's going to be the most simplified, expanded version. Okay, that's if they give it to you condensed and they say, hey, flatten that out like a pancake. Okay, now flip the page. What if they say, oh, let's accordion it, put it together. Let's go do 23.
We're just not doing 14.
Yeah, you can skip 14. I hate 14. It causes a lot of questions.
It's a strong word.
It's true. You guys, I got to go like this. How am I going to do that?
20 and
Ooh, she says you can't do anything until we move that up. I love that. What else do we have to move? Move that 5 up. So what would I have before I try to condense? Let's just move the 20 and the 5. Log base, 6 of u to the. So we really have 3 levels here that I want y'all to see. That's 1 level, 2 levels, 3 levels. We're going to add to that what? Beautiful. Now, I need to combine 2 logs to 1. If I've got addition, how am I going to do that? Multiply. We got log base 6 of.
U20 V5.
Okay, you sound like a robot. U to the 20th. Done.
That's what I said.
Oh, he's saying that?
Yeah. Order of operations.
Yep, that's fair. I'm just wondering. Let's remind ourselves of these formulas real fast. You don't need this guy. This is just pert. Ev, I agree. This is a lot. You do not have to do all this, even though I'm giving you 50 minutes. Guys, anything with an equals, less than or greater than, you can just make that equals, just so you know. You do not need to worry about less than or equal tos. We got pert, and then let's go to the last page. Practice one of these, because this is using those properties and then putting them together. So let's go with, let's go do 19. What we got? We got to combine them and get what?
Log base 8.
Of?
2 times 4x squared.
Are you cool with saying 8x squared?
Yeah.
Because that 2 times the 4x squared gets me 8x squared? Okay, then this is the hard part. Where do we go from here?
Oh, no, you have to do something else.
You have to.
Eat out.
Yep. A little swifty cheat.
8 to the equals? Yeah, so you guys, this, I agree. We are not good at that transition there. That's what you're going to be uncomfortable when you're like, I don't know what to do. Go like this. Every time. Guys, what would I do now? Divide by 8. And then we have x squared equals 1. I'm perfect. I never make mistakes. X equals 1. Square root of 1 is 1. So you guys, did I put an answer key of this up? Of course I did. Let me show you where it is. You're staring at that answer key. You've done, I wouldn't do like the first problem in each section. I would maybe do middle and the last question.
First, third, fifth.
First, third, fifth. You're getting a little variety. I like that. Then see how you're doing with those. If you're good with them, don't do the whole section. We got people to see, places to go, tracks to run. Right, exactly. So, you do not need to do this whole thing. The formative will be on Thursday. Yeah?